Just like the last review, I wanted to go through at least one of each type of problem that you'll see from the review. Of course, you're not going to have this many problems on your actual test. To get an idea, if you see a 1A, 1B, 1C, that means you're going to get one problem like that. A 2A, 2B, 2C, that means you could see another problem like that. Okay? I'm going to go through and I'll do 1A. If there are any ones that you're not sure about, please come in and get help or message me on Remind. Don't forget that this review is something that you do need to turn in to me. So if you do have questions, come in and I will help you out. And more importantly, I want you to do well in the test. Okay. Starting with 1A, find the x and y intercepts of the graph of the linear equation. And we want to write these in ordered pairs. Now remember, to find an x-intercept, you set y equal to 0 and you solve for x. To find a y-intercept, you set x equal to 0 and then you solve for y. So I'm going to go ahead and go through that here. I'll start with my x-intercept. Now I'll put in parentheses, remember, y equals 0. Okay, so when I write this 3x, some of you might not even write 4 times 0. You might just not even put it there, which is totally okay. I will put it here because I want you to realize that 4 times 0 cancels out. 4 times 0 is 0. Then I'm left with just a 3x equals 12. Divide both sides by 3 because I want to get the x alone. And I get x is equal to 4. Now, to get full credit, you remember that we need to write our intercepts as ordered pairs. I found my x, it's 4, and I remember we said our y was equal to 0. So as an ordered pair, that would be 4, 0, since remember in the first letter in our parentheses, or an ordered pair would be x, and that one would be y. So this one here is 4, 0. Now to find my y-intercept, it's very similar except I do the opposite. Now if I'm doing my y-intercept, remember we are setting x equal to 0. I have 3 times 0 plus 4y equal to 12. Remember 3 times 0 is equal to 0, so really all I've got is 4y equal to 12, and I'll rewrite that right there. Now I'm going to go ahead and divide both sides by 4. So I can get that 4 over 4 to reduce, or at least the 4 to reduce. And I've got 12 divided by 4, which is 3. Now remember that we said our x was equal to 0 and we found our y to be equal to 3. So this corresponds to the ordered pair 0, 3. All right, moving on, let's try something like A. Now, I'm sorry, 2A. Now notice the difference between 1 and 2. Everything, like our x's and our y's, were already on the left side. They're actually in standard form for 1A since the 3 is positive. For 2A, I've got x's on the left and I've got the y's on the right, and that's totally okay. I'm still going to do the same thing. I'm going to either set my y equal to 0 or I'm going to set my x equal to 0, depending on which intercept I'm looking for. So let me start again with the x-intercept. Remember, that's when y is equal to 0. And let's see, we've got 5x plus 15 is equal to negative 3 times 0 plus 45. Negative 3 times 0 is 0, so really what I've got is 5x plus 15 is equal to 45. I want to get the x's by itself, but if I'm doing inverse order or reverse order of operations, I'm going to subtract the 15 to get rid of that first. 15 minus 15 is 0, and right now I've got 5x is equal to 30. Divide both sides by 5, and I get x is equal to 6. Now recall, I said that my y was equal to 0. I found my x is equal to 6. This gives me an ordered pair of 6, 0. Now let's find our y-intercept. Again, our y-intercept is where x will be equal to 0. So let's go ahead and plug 0 in for x, and I will write out the rest of the equation. 5 times 0 is 0, so I have 15 is equal to negative 3y plus 45. I want to get the negative 3y by itself, so I will subtract 45 from both sides. 45's cancel. 15 minus 45 would be negative 30, and I have a negative 3y left over. And lastly, divide both sides by negative 3 to get y is equal to a positive 10. Since I'm doing a negative divided by negative, the negative signs become positive. Y is equal to 0. And we said x was equal to 0. We found y to be equal to 10. That corresponds to 0, 10 as my y-intercept. Okay? So that's 1 and 2. Let's move on. Number 3. 3a. Now, we've gone through, and one of the ways we did graph lines was using the slope-intercept form. And just a quick refresher, that's y is equal to mx plus b. However, this is very convenient, and we're kind of already in the mindset of using the intercepts. So while you can use your slope-intercept form, or maybe a different way to find some points to graph this line, I'm going to kind of stick with this trend that we've been doing to find the x and the y-intercept and find 2 points to graph the line. So if you have 2 points on the line and they're not really the same, then you can just draw the line straight through them. So that's really what I'm going to do here. And now, like I said, you could change this into slope-intercept form if you wanted to, but I think this might be a little bit easier if we just find these points. Now don't forget, this is setting y equal to 0. So I have negative 8x plus 12, switching the y with the 0 is equal to 24. 12 times 0 equals 0, so I have a negative 8x equal to 24. Divide both sides by negative 8, and I get x is equal to 24 divided by negative 8, gives me a negative 3. We've set y equal to 0 and found x to be negative 3. So my point is negative 3 comma 0. Let me plot that. Remember, when we're starting from the origin, if we're going in the x direction, that's going to be left or right. Oh, what is this here? And if it's negative 3, we're going to go 1 to negative 3 spots from the origin. And because our y is equal to 0, we'll neither go up nor down. We will stay right there. So let me plot this point there, and I'm going to get rid of these little lines just to make it a little bit more clear. Now I've got 1 point. Let's find the other intercept, the y-intercept, to get an extra point. So I'm going to set negative 8 times 0 plus 12y equals 24. Negative 8 times 0 is 0. I have a 12y equal to 24. Divide both sides by 12, and I get y is equal to 2. So as a reminder, we set x equal to 0, found y to be equal to 2. That gives me the intercept, the ordered pair, of 0, 2. Now let me plot that. Same deal, start at the origin. Because my x is 0, we will neither go right nor left, but we will go up, and we'll go up 1, 2. So let me put a point right there. Okay, now I got all I need. I can just go ahead and make a line, and maybe make it in pink, that goes through these points. Okay, and I want to make sure that this is a line that goes through the points. They don't just like go from here to here, which sometimes I will see students do. And I use the arrows to indicate that this line will keep going forever in either direction. Let's check out 4a, and I think we're doing the same thing. Graph the linear equations. Now I'm going to give you a heads up. A problem like 4a, 4b, 4c, we are going to get either our x or our y cancel out. Now when we get one of those that cancel out, then we're going to have either a straight horizontal line or just a vertical line. Now I will do 4a, but let me give you a clue that 4b will be a vertical line because we don't have any y's. 4a, we have a horizontal line, and I will show you what that looks like here. Okay. For this problem here, I want to go ahead and convert it into slope-intercept form. Now remember, again, slope-intercept form is y equals mx plus b, where m is our slope and b is the y-intercept. Now x and y would be any possible point to plug in. So if I want to get the y by itself, first I will subtract 5 from both sides and get 2y is equal to -6. Simplifying for y, I will divide both sides by 2 and get y is equal to -3. Now, because I don't see this part, this is telling me that my slope is actually equal to 0. Okay, because if I plug this in, it would be y equals 0 times x, and then I would have the -3. Because anything times 0 will be 0, this actually cancels out, and we don't have to write it. So that's why we get to this form right there of y equals -3. Now when you don't have a slope, we actually have 0 slope here, we have a flat line. What I want to do here is go down to where I do have a y-intercept, which is -3, and since it's neither going up nor down, it's just staying flat because there is 0 slope. Positive slope would mean it would go up, negative slope would mean it would go down, no slope would mean it would just stay a flat line. Okay, now when you do 4b and you get x is equal to something, then you are going to find where is it crossing this and then plot it. So say it was said -3, it would be here with the line straight down here. Now I have no idea, I haven't done 4b yet, so it may not be -3. Let's see, let's go to 5a. The points represented by the table on a line. Find the slope of a line. Yeah, it's not very clear. I don't know if maybe it was a typo, but what I want to use is any 2 points. Now, any 2 points would come from these columns in this case, where this would be like point 1, where this would be my x1 and this would be my y1, and perhaps this is my point 2, where this is my x2 and this is my y2. Now remember, the equation for slope is m is equal to, remember, rise over run, so I have to do y's over x's, y2 minus y1 over x2 minus x1. Now, I could have picked any of these points and I could have done a bunch of different combinations, but I will follow along with what I've got here, doing m is equal to -2 minus -2 all over 2 minus 1, and I get a positive, so really I get a 0 over 1, and in this case 0 over 1 equals 0. So actually I have no slope for this particular problem. Okay, continue on with 6. I want to do the same thing that I did up above in 5a. Pick any of the points that you want. I'm going to call this my point 1, and this my point 2. All right, therefore, I've got a point x1, y1 is equal to 2, 10, and x2, y2 is equal to 4, 15. Now I'm going to use the same formula up above that I used for my slope. M is equal to 15 minus 10. And take 4 minus 2. So I have a 5 over 2, and that's my slope. Okay, that's all I have to do for 6. Number 7. I need to identify the slope, the y-intercept, and the x-intercept of the graph of the linear equation. Now, if I'm looking at 7a, something that's nice about this is it's already in slope-intercept form. Now, in the last video, we talked about what slope-intercept form was, which is y equals mx plus b, where m is the slope, okay, specifically the m, not the x, and b is the y-intercept, okay? So keep in mind that x would be equal to 0, and then whatever that number for b would be, that would be my y-intercept. So I can easily tell my slope is -3, and my y-intercept is 2. So if I write that as an ordered pair, that'll be 0, 2. Okay, so that's the easy part. The part that has a little bit more work is finding our x-intercept. Now remember, to find our x-intercept, we are setting y equal to 0. So let me do that. Instead of writing y, I'll put that equal to 0, equal to -3x plus 2, and then try to get the x by itself. Subtract 2 from each side. I have a -3x is equal to -2. Then divide both sides by -3. And my -3's reduce. I have an x equals to a positive 2/3. Writing that into intercept, or actually ordered pair form, that would be 2/3, 0. All right. Let's check out something like 8a. Let's find our slope, a y and x-intercept. Spoiler alert, we may not have all 3 of these things. So let's start. This one is not already in slope-intercept form, but I can convert it into slope-intercept form by solving for y. So if I do that here, first thing I do is add 2 to both sides. So I have -2 plus 2 cancels, and then 3y equal to 6. Divide both sides by 3 and get y is equal to 2. Now I have a case where I had in a problem up above. I think it was, where was that at? Oh, this one right here, 4a, where I get an x or a y that cancels out. Now when I have this, I may or may not have an x / a y-intercept depending on what kind of line I've got. In this case here, I did not have an x-intercept. I did have a y-intercept. It went through -3, but I didn't have an x-intercept because it never actually touched my x-axis. Now I could have an x-intercept if I had a line that was flat left and right like this, but that would mean that this actual line was up here, and every single point would actually be an intercept. But I don't have that here. Oops, I didn't mean to do that. So let's look at what we've got going on and see what we might have. Now in this case, we have an example of where we have a horizontal line. Now, if you remember that problem that we were just talking about, in our slope-intercept form, if we don't have this term, it means that our slope is actually equal to 0. So my slope is equal to 0. And it didn't matter what x would be because anything times 0 would be 0. So my slope is 0 here. My y-intercept, well, this is my b right here, because that's the only thing that really shows up in this equation. So I can convert that into 0, 2. Now, because my line doesn't go through x equals 0, I don't have an x-intercept, and it looks kind of like what we had up above here. For our problem of y, I think it was y equals 2. For our problem of y equals 2, and actually I'll do it right here on this graph since it's blank. You would have a point right there, and it would just go straight through here. Okay, now this never touches the x-axis, so it doesn't have an x-intercept. You could show and try to solve to show that there would be no solution for x by doing this. Let's see. Trying to find an x-intercept by setting y equal to 0 and then going -2 plus 3 times 0 equals 4. And then you get this is equal to 0, -2 is equal to 4, which is not true. And I don't even have an x there. So even if I used this form and made it into y equals 0, since that's my slope, times x plus 2, I would get the case where 0 equals 0x plus 2, and then 0 is equal to 2. So I have no x-intercept. Let's check out the next set of problems. Okay, here we go. 9. Write an equation of the line in slope-intercept form, if possible. Okay, so I'll tell you for these particular examples, they are all possible. I will show you how to do 9a, and I will show you how to do 10a. Okay, to start with, if I'm doing slope-intercept form, I need two things. I need the slope and I need the y-intercept. Now, I've got a y-intercept right there of b is equal to 9. Let me figure out what the slope would be. Now, remember, we are going rise over run, so I have to figure whether it's going up or down. And I'm reading my graph left to right. Okay, a lot of times students will go right to left and get the opposite of what they're looking for. And in this case, I'm going to go down 1, 2, 3, 4, 5. Let's see. So m is rise over run. So I'm going to put the -5 there. And it's going to the right, 1, 2, 3. So my slope is a -5/3. Now I've got everything I need to write this into slope-intercept form. Here I've got y is equal to -5/3 x plus 9. All right, now let's do 10a. Here I've got a y-intercept at -11. My slope, I'm going to read this point right here and then go left to right. So my graph is going down, so I'm going to go down 1, 2, 3, 4, 5. Over 1, 2, 3. Okay, so this one looks very similar to 9a. Y equals -5/3 x. However, our intercept is at -11 instead. 11. Now these are formulas you need to know. These will be very helpful to know on the test. Standard, not too big, but since I wanted you to know slope, intercept, and point slope, I figured to give you an opportunity to get an extra easy point, going over standard form would be important, something I can add on there too. So slope, intercept form, we've already gone through a bunch of times. y equals mx plus b. And point slope is y minus y sub 1 equal to m times x minus x sub 1. And then standard form, ax plus by is equal to c. And not that I will require you to write this, but a would have to be positive for this. 12a. Write an equation in point slope form of the line that passes through the given points. Now for point slope form, as we wrote up above, we need y minus y sub 1 is equal to m times x sub minus x sub 1. I've got two different points. I really only need one, okay? But I don't have my slope. But I can find my slope by using my slope equation, which is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let me call this my x1, my y1, my x2, and my y2, and then just plug in this information here. So I've got 3 minus, that's my y2, 3 minus negative 1, which is my y1, and my x2 is negative 1, and it's subtracting a 3. Here I've got plus 4 over negative 4, and I want to put that negative out in the front and simplify 4 over negative 4, which is negative 1. Now I know my slope then, it's m equals negative 1, and I can pick either one of these points. I could pick this point or that point, either one will be acceptable. I'll use the first one and say y minus negative 1 is equal to negative 1 times x minus 3. And then simplify that. Maybe you simplify that in the previous step. Y plus 1 is equal to negative 1 times the quantity of x minus 3. All right, let's check out 13a. Same process. I want to find my slope. I have negative 1 minus negative 5, negative 7 minus negative 3. Got positives here and on the bottom. So I've got negative 1 plus 5 is equal to 4. Negative 7 plus 3 is negative 4. And I get negative 1 again. So it won't always be negative 1. Just seems to be a coincidence for these particular example problems. Then again, I can pick any pair. I will pick this one right here and say y minus negative 5 is equal to negative 1 times x minus negative 3. Both of these simplify to pluses, y plus 5, negative 1, x plus 3. That's my answer. 14, I'm going to leave for the next clip. All right, I got 14, and we might be able to finish all of these in this last little video. 14a. Determine which of the lines, if any, are parallel or perpendicular and explain. Now, quick review. If two lines are parallel, they have the same slope. And then we could get lines that have the same slope and even the same y-intercept, and really those lines actually overlap each other. But most often you have two lines that have the same slope, so they both go at the same rate, and then they would never cross each other. Okay, so if they have the same slope, then they are parallel. And you can tell that they don't overlap or they do overlap depending on their y-intercepts. Now, if they are perpendicular, or you know that they're perpendicular, if, let me use maybe orange, their slopes are opposite reciprocals of each other. reciprocals. You can spell check that for me. Opposite reciprocals of each other. And then for both of these, we're talking about comparing two different lines. So if two different lines have the same slope, then they are parallel. If two different lines have slopes that are opposite reciprocals of each other, then they are perpendicular. Okay. Now opposite reciprocal, of course, means if I had an example of -5/1, maybe make it -5/4. The opposite reciprocal would be +4/5. Another example would be a +2 and turning that opposite reciprocal of -1/2. Okay, so I want to look for all that. Now it is very helpful if I can tell what my slope is. Okay, there we go. Not working with me very well. So if I had them in slope-intercept form, that would help me. Now line A is in slope-intercept form. I can easily tell that 3/4 is my slope. And while it may or may not be important, my y-intercept is at 1. Okay, and I'll just leave it as b = 1. Now for line B, sorry, I'm having trouble with this. It is not in slope-intercept form, so I want to do that. I want to convert it. Now all I would have to do here is divide everything by -3. So I can get rid of this -3 on the left. Got y is equal to -4/3 x plus 1. Okay, now here I've got my slope of -4/3. And I can already tell that 3/4 and -4/3 are opposite reciprocals of each other. So if I wanted to, I could go ahead and say line A and line B are perpendicular since their slopes are opposite reciprocals of each other, and you can add that on if you like. Just because we could say that our b is equal to 1. Not that really matters here. What it does mean is that they intersect each other at the same, since they have the same y-intercept, they're actually crossing each other at that intercept. Let's check line C now though. In this case I have to divide everything by 4. I have a y equal to -3/4 x plus 9/4. 1 second. Yeah. Now here my slope is -3/4 and my b is equal to 9/4. Now if I compare this slope, -3/4, with both of my other lines, the first being line A, even though they both have the 3/4 part, one's negative and one's positive, so they are not parallel. And it's not a reciprocal, it's not -4/3, so it's not perpendicular. So line A and C are neither parallel nor are they perpendicular. Now if I compare it to line B, well, it's not perpendicular since they both have a negative slope, and they are not parallel because their slopes are not the same. So really for 14a, only line A and B have any type of relationship is in terms of being a parallel or perpendicular, and they are perpendicular for this problem. Let's move on to 15a. Use the given information to graph the linear function. So here they give me a point and a slope. Remember, this is a rise over run, which means I go up 1 to the right 2. All right, so let me plot this first point at 2 comma negative 1. And I'm going up 1 to the right 2, so my next point would be right there. And once I plot 2 different points, I have enough to graph a line. And it's as easy as that. Let's check out 16a. Now this time I don't have a slope, but I do have 2 points. And as we said, you only need 2 points to graph a line. So I'm going to go ahead and graph them each here. Let's do maybe this orange here. 1 comma 4 would be there. -2, -3 would be right there. If I connect these lines, maybe do it in red. Just like that, and I'm done with 16. 17. Okay. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the amount of water remaining in the tank as a function of time. Okay, so this one here, first I have to check that it is a linear function. Now in our last unit, we looked at tables and saw if they were linear. And the way we did it is by showing that the inputs and the outputs increased at the same rate. Now normally we have x be our time, and we'll let water be our y for this particular problem. From 8 to 10 though, I go up 2, 10, 12, up 2, 12 to 14, up 2, and all of them are up 2. So let's check the y's. Okay, and in this case I'm going down 5, down 5, down 5, down 5. So I do indeed have a linear function. Yes, this can. Yes, this can, because it has a constant rate of change. Now that would actually be my slope. M is equal to -5 over 2. And of course I could, use my slope equation of y2 minus y1 over x2 minus x1. But if these are my y's, this is my rise, down 5 over 2. This is just a little quicker way than having to prove the same thing. Now I have my slope, but if I want to write it in a linear model, I actually want it to be in slope-intercept form. Now I don't know what my y-intercept form is, but I could write this in point-slope form because I know the slope now, which is -5 over 2. Oops, that's on the highlighter. And I know a point. Actually, I know 1, 2, 3, 4, and 5 different points, and I can pick any one of them. Let me pick 8 comma 155 and plug that into my point slope form. And a reminder, that would be y minus y1 is equal to m times x minus x1. Now let's see here. I want to put this as, I know my -5 over 2 x, and subtract 8, and let's subtract 155. All right, now if I want to put this in slope-intercept form, I need to get this y by itself. So let me do that. First, let me multiply the -5 halves to here and there. Let's see. y minus 155 is equal to negative 5 over 2x. And then I get a, let me do that math over here on the side. Negative 5 over 2 times 8, which is the same as 8 over 1, is equal to negative 40 over 2 or negative 20. So I got a negative 20 there. Next thing I'm going to do is add 155 to both sides. And to get y is equal to negative 5 over 2x plus 135. Now, if I want to write that as a function of time, I'm probably just change up a few things. And if I want to put it as a function, I would say f of x is equal to negative 5 over 2x plus 135. That would be perfectly okay, or if I want to make it f of t, so it models more like t stands for time, I could do it like this as well. Okay, either one would be good. Please come and get help on this one, because I know that there's a lot going on in this problem, and it's probably the most complicated problem on this test, if not one of the top few. So check out 18, which could be the other more complicated one, or more complicated, or as complicated. So let's check it out. A website hosting company charges an initial fee of $48 to set up a website. The company charges $44 per month to maintain the website. Let's write a linear model that represents the total cost of setting up and maintaining a website as a function of time. Now, a couple things to pull from this. There's an initiation fee of 48. Initiation fee, and that is actually, that corresponds to my y-intercept, because it doesn't matter what x will be, which will stand for the number of months. At x equals 0, I have to pay $48. So that's my y-intercept. Per month, I have to pay $44 a month. Now that would correspond to the slope. So if I combine these two things into an equation, I could put y is equal to 44x plus 48. Find the total cost of setting up the website and maintaining it for 6 months. Well, that would be like my x was equal to 6. Now, let me kind of put this into function notation and say f of x is equal to 44x plus 8. Then if I want to know what 6 months, then I'll plug in 6 for my x. Let's see here. 6. I've got 44 times 6 is 264 plus 48. Oh, this should be a 48 here too. This is going to be equal to 312. So it would be $312. Now, a different website hosting company charges $62 per month to maintain a website, but there's no initiation setup fee. You have $620. Oh, I'm going to have to continue on and break this clip up in a minute. So continuing on, you have $620. At which company can you set up and maintain a website for the greatest amount of time? And explain. Now, what I want to do is compare, like if I had set both my equations equal to 620, which one would give me a higher x value, because that would correspond to the number of months. Remember, x would be the number of months. Okay, now I already have an equation from part A for the first company, but let's write an equation for the second company. And in this case, the initiation fee is 0, but it does have a higher monthly at $62. per month. Now, that still corresponds to the same things. I would get y is equal to 62x, and I could put the plus 0, but I'm not going to put it because it's unnecessary. Now, if I set both of these equal to 620, I could see which one gives me the higher x value. Whichever one does is the one that would give me the more bang for my buck, essentially. So let's try it here. 620 equal to 62x. Divide both sides by 62 and get x is equal to 10. So if I go with the different website hosting company, I would get 10 months. Now let's compare with the first company using this y equals 44x plus 48. Plugging in 620 and solving. I would subtract 48 from both sides and get 44x is equal to 572. I have 572 equal to 44x. Divide both sides by 44 and get x is equal to 13. So this would be 13 months. Okay, so you would get the most value, most time, I should say, from the first company. Okay, and then this work would actually justify it to me. Explain, and you could say something, the first company you get 13 months, the second company you would only get 10 months. Okay? Last two definitely a bit more of an explanation going on, but those are really the only two word problems on the test. And that's it.